Greetings, Saints. Today we're going to go get started with lesson 5.5 with this triangle congruence through side, 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 or SSS. So far, we have had only one method for proving congruent triangles, which was through side, angle, side, or side SAS. We did a construction in class, so make sure that you have a compass for the next class, because I want to go ahead and show you guys really where side, 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 and side, angle, side wind up being the same construction ultimately. And here we go. Not the same, but they're very similar constructions. So give you guys a once we do the demonstration of side, side, side. Right now, we have it where I'm going to give you guys the following, which is going to show, oops, some congruence here in this figure for these share a side, and we have K, L, M, and N. So here's our given, is that we're going to, we're given two sets of congruent sides, which was side KL, which is congruent to side LN. Moreover, we have KM, which is congruent to side MN. All right? And what we are going to prove is we have congruent triangles. Triangle KLM, which is going to be congruent to triangle NLM. All right? So let's take a look at what we're trying to do, because right now we have nothing about our angles that are going to prove congruence. But we, again, it's going to be the idea being that we only need three pieces of information, right? Right now we have two, and we have an S and an S. And so far we've needed two sides and then an angle, but it had to be included. Otherwise, it didn't count. It didn't work. Or we can actually go with three sets of sides, right? SSS. So let's go ahead and set up our two columns, right? And so far in all of the quizzes that I've graded, I've seen students at least set this up and then even give me the following, which is they got that first step down, KL congruent to LN, KM congruent to MN. Okay, that's our given. And then now what we need to do is our burden of proof. So how we're going to prove this thing is we're going to use either SSS or SAS. Okay, now to start, we had these two, right? This guy and this guy, right? And then this guy and this guy. So it's two sets of sides. So we either have this one or this one. So we either need an included angle or just that third side proving congruent. So how could we do that? Could we prove this third side to both triangles? Well, it belongs to both. So there we go, guys. We don't have to use much imagination. We can just say that LM is congruent to itself, LM, and that is, of course, we know the reflexive property. So we're there, right? We have actually done our proof, and then we've shown three sets of congruent sides. We have three sets of congruent statements within our statements column, and then we can actually now successfully say that we have triangle KLM congruent to triangle NLM, and this is through SSS. Now, it's important that we cite the correct theorem here. If we don't, then it's actually going to be incorrect. We can't just say whatever we want. We have to use the one that we're actually utilizing here. Okay? Now, gentlemen, this is a fun one here because I have told you there's only three-letter answers that are acceptable here. Okay? So I'm going to give you guys a two-letter answer that's really a three-letter answer. And it's this. We're going to take a look at this guy. Take a look at this guy. And we have two triangles here. We have this triangle, which is a right triangle. Okay? And they're going to be congruent triangles ultimately. So it's okay if you set them up that way. So we have triangle ABC and DEF. Both right triangles where AC and DF are congruent, AB and DE are congruent. Okay? And here's how we're going to show this. These two triangles are congruent. Triangle ABC is congruent to triangle DEF. And the reason why it is this is what's called the hypotenuse leg theorem. okay? Or HL is what we always put down for short. Hypotenuse leg. All right. Hypotenuse leg theorem is really an extension of side, 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 because it's really showing through the Pythagorean theorem, because we have a right triangle, right, that these, all three sets of sides will be congruent. Okay. This is also the lone exclusion where you guys don't have an included angle, and this is angle side, side. This is your lone exclusion. Okay. And here's why. Due to the Pythagorean converse, we're going to have that BC is going to be congruent to FE. Okay. These guys are congruent. Put the little congruent sign right here. Here's why. If triangle ABC is a right triangle, right? This is the Pythagorean converse. Then the Pythagorean theorem applies. So if ABC is a right, so it's this. The Pythagorean theorem showing that a squared plus b squared is equal to c squared. Okay. Here, a and b are my legs, and c is my hypotenuse. And remember where C is, the hypotenuse. It is opposite the right angle. All right. So it's this, for example. Let's just take, let's say it had a squared plus 4 squared equal to 5 squared. Okay. What we're going to show here is that what this third side would have to be would have to work within the Pythagorean theorem. Okay. So for example, a squared it plus 16, right, would be 4 squared would be equal to 5 squared, 25. Or a squared. The next step is that I would have to subtract 16 from both sides, right? Leaving me that a squared is going to be equal to 9. And then to get that, I'm going to take the square root. So a would be equal to 3. So for every single time I have these dimensions, right? If these guys were congruent, right? If this were a 4 and this is a 5, it means that df is a 4 and de has to be a 5. So whatever I solve for here, these values will always have to be the same because it's a right triangle. So this is that lone exception. If you have a right triangle and you have a leg and a side, or a leg and a hypotenuse, pretty much if you have any two of the sides in a right triangle, you have congruent triangles, right? If you have, even if I had done it here, right? Let's say that, oops, see if I can actually just erase this real quick. If I had these two sides were congruent, okay? Well, what do I have then? Well, then I don't have side angle side, so it's still going to be congruent. So as long as I have two of the sides of a right triangle congruent, correspondingly, and right triangles, then we've got congruent triangles. Okay. Next, let's do our proof. Last one for today. We're going to draw a rectangle. Okay. And draw a diagonal across the rectangle, giving me, and I'm going to have some congruent sides. I have P, Q, R, and S. And what we're going to be given is just that PQ is congruent to RS. And angles Q and S are right angles. Okay, and we're going to prove some congruent triangles. Triangle RSP, the order doesn't matter, to triangle PQR. Right, because RS corresponds to PQ, but so does SP to QR. All right. So here we go. Let's do our proof. Set it up, 2 columns. Statements on the left, reasons on the right. Restate what I had here. Back up top, PQ congruent to RS, angle Q, angle S are right angles. Okay. And here's what's fun. We're going to look at that, right? And then say, hey, it's correct. And that's already going to be points that we have. Okay. Now, this is usually a good way to just get started. Now, what else do we know about this? Well, think about what they both share. Don't they both share this side, right? So then we're going to, of course, share that PR is going to be congruent to itself because it's going to be shared by both triangles, and that's going to be reflexive. Okay. Moreover, now I have how many sets of congruent parts? I have this and this. Okay. So I have 2 of my sides. Now I need a third part. Right? I need 3 statements. So this is going to be where I'm going to effectively do side, side, side. But the way I show that this PS is going to be congruent to QR is because it is a right triangle. So we know that angle Q is congruent to angle S, and that's we weren't told exactly that, but we know that Q and S are both right angles. Well, we know then they're congruent because all right angles are congruent. That is a reason we have used before. So there we go, guys. We have our 3 parts. It's not angle side side. If you put that, it will be a big fat wrong. It's incorrect. But we know that RSP is congruent to PQR because it's our exception. With ASS, it is HL, hypotenuse-like, which really means SSS. And if you gave me SSS there, even though you just told me angles were congruent because they're right angles, I would give it credit. Okay? And there you have it. I'll see you in class.